Okay, this is the second half to determining the empirical and molecular formula, or determining formulas. Okay, so in the last video we learned how to take percent compositions and find the empirical formula. Now we want to know what the molecular formula is. In order to do that, you have to have the molecular weight, which is also called molar mass, and you have to calculate. So you have to calculate this, the empirical weight. And you do it just the same way as you do the molecular weight. But we're going to calculate this. So you're going, and this is always given. This has to be given to you. There's no way for you to know it. Okay? So you're given the molar mass or the molecular weight, and you calculate the empirical formula weight. So you take the 2 and get N. And N should be always a whole number. If not, you've made a mistake somewhere. Or I made a mistake. That's happened too. But okay, so that should be N. All right, so let's do an example of that. So this is number 76 in the book. Adaptic acid is used in the manufacture of nylon. The composition is 49.3% carbon, 6.9% hydrogen, and 43.8% oxygen by mass, and has a molecular weight of 146. What is the molecular formula? So since I'm given first the percentages, I have to find the empirical formula first. Okay, so we're going to start to do the same process. I take the percents given and make the masses. So I have 49.3 grams of carbon. I have 6.9 grams of hydrogen, and I have 43.8 grams of oxygen. Okay, I divide each one of these by its atomic weight. So carbon is 12.01, and I get 4.105. I divide hydrogen by 1.01, and I get 6.832. And I divide oxygen by 16, and I get 2.738. Okay, so this is step 1. Step 2 is to look at these 3 and divide all of them by the lowest one. So that's this one. So I'm going to divide all of them by 2.738, divide by 2.738, and divide by 2.738. So this one's 1. This one comes out to be 1.499, which is 1.5. I cannot round this. This is not plus or minus the 0.1. Okay, so I have to recognize the 0.5 is 1/2. So I have to multiply it by 2. When I do this one, I get equal to 2.495. Again, not within the plus or minus. This is basically 2.5, okay, which the 0.5 again is 1/2, so I'll multiply this one by 2. So 1.5 times 2 gives me 3. 2.5 times 2 gives me 5. And I have to do all of them by 2, so 1 times 2 gives me 2. So I get C3, so carbon was 3, hydrogen is 5, oops, 5, and oxygen is 2. Okay, and so this is the empirical formula, just like we did in the last problem. But this time we have to go a step further. Okay, we have to take the empirical formula to molecular formula. So I need to find the empirical formula weight. Okay, and you do it just like you do the molecular weight. Okay, so I've got 3 times the 12.01. This represents my carbon, plus 5 times 1.01. That represents my hydrogen, plus 2 times 16 represents my oxygen. So when I add all those up, I get 73.08, and I'm going to put this in units of AMU because this is in AMUs. Okay, so since this is a whole number, I'm going to use this whole number. So N is the molar mass divided by the empirical formula weight. So it was 146 divided by 73, and I get 2. So that means I take 2 times the C3H5O2 to get C. 2 times 3 is 6, 2 times 5 is 10, and 2 times 2 is 4. And this is my molecular formula. And if you're doing this on a test or a worksheet, you need to identify which one's your empirical formula and which one is your molecular formula. And there are cases in which they are the same, okay? And if that's the case, then you just simply use the same arrows to point to both. You just have to identify it both as empirical and molecular.